Most people stare up into space with wonder. Yet we have this almost alien world on our own planet, just teeming with life. It's a world completely out of sight and out of mind.
Coral is a fundamental part of a huge ecosystem.
This short video is a very good representation of what the world's coral reefs are currently undergoing. Huge stress and from both anthropogenic as well as natural causes. And this causes reefs around the world to degrade rapidly. I'm Ilja Voorsmit, and I really like to talk to you about my thesis subject, reef fish attraction to restored coral reefs. And as I will continue through my presentation, I'd like to take you on a little exploration about the area where I did my study, what my idea was. Then we will move on to my method development, continue to the results, and finally the conclusion and discussion. And as you can see by this beautiful picture, we are a diver. And as I continued through my project, I got more knowledge about everything, and I ended up in the zone where coral reefs are most of the time located. So let's go. Where are we? Well, I'm the third one here, and I won't bore you with all the specifics about where I did my research, but I also was in the Seychelles. I was on a super tiny island on the east coast called Cerf Island, and it's only inhabited by 4 resorts, and nothing else is there except fringing reefs. So what are corals? Corals are so the reefs around Cerf Island are built up by scleractinian corals. However, in 1998 and in 2016 bleaching events in this area, almost 90% of the corals were lost. And my idea was part of a project called the Small Grants Project that funded, together with the local hotels on the island, a restoration effort of 500 square meters. And I was very interested not in only the restoration effort, but also in what does that do with the area, for instance, with the fish. Are these fish going to be attracted to the area that you are restoring? So as I developed my idea, I also needed to develop a method to collect this data. First of all, I needed to specify the locations I was going to look at. I needed to make sure that I had the proper equipment and the right survey methodology. Then I needed to figure out how I was going to do the transplantation, and in the end I also needed to make sure that I did a good analysis of that. So the location, first the selection, and to make sure that I monitored the same location over and over again, I had to mark these. So the selection, this is the northwest point of the island, and I chose 3 locations in combined with also the reef areas that were there. So this is the Cerf Island resort location, this is location Jetty, and this is the location at the outside of the coast of a hotel called L'Habitation. And in each location I had 3 sites. So the first site I assigned was yellow, and that, as a yellow color, which is the healthy reef, or visually appearing healthy. Then I had a degraded reef, and I had a second degraded reef in red, which I assigned as the area that I would execute transplantation later on. For marking, I measured a length in the areas of 25 meters and a width of 5 meters, so that each site that we saw here has a surface area of 125 square meters. At each corner, I placed a rebar in the sediment, and to this rebar I attached a water bottle to make sure that I could find my area over and over again. Then the equipment, so I needed a transect line. The island and the office I was working at had a broken transect line, so that was not much of use. So I built my own one. It has an interval of every 5 meters, and I also made my underwater slate with 71 species that I identified using photo ID, but I will come to in a minute. So, oh yeah, the line was, by the way, of a floating device, so I had to weigh it down with dive weights to make sure that it would stick on the substrate. So the survey methodology, I use the underwater visual senses. And normally this is done scuba diving, but due to logistical limitations of the ability to scuba dive on the island, I did it snorkeling. This is a selection of fish that I photo ID'd, and after photo identification I looked up the fish on Fishbase to see what kind of feeding behavior they had, and according to their feeding behavior I classified them in a functional group. Here you see me putting out my transect line and me surveying the fish. Then for the transplantation, MCSS, the organization I worked for just as the other ones, had a large-scale nursery built with approximately 3,000 fragments scattered across 3 large-scale nurseries which had ropes of 20 meters in length. I took those ropes with coral fragments to this location where I did my transplantation. We cut them up in small pieces from the ropes. Then we put them while diving on the substrate, as you can see here, and using a specific mixture of underwater cement, we fixed them to the substrate. And although this picture is not really clear, here's my corner marker of one of my sites, and these are fragments that we transplanted. Then for the analysis, I used a two-way cross-factor ANOVA with site and location on my abundance, and then for species composition and functional groups, I used the PermaNova, which I then visualized using an NMDS, and to see what the diversity was in each of the sites, I used the Simpson Diversity Index inversed. So that was my methodology. Then I went swimming and I went snorkeling for 3 months, and I collected a total of 7 samples, 3 before the transplantation and 4 only after transplantation. That was due to a very bad visibility, I would say almost 90% of the time, in which I could not see my 5-meter mark in front of me, let alone I would identify a fish. So that was a bad thing. But then for the results, so the results section, I made it up in 3 sections. First one to quantify what kind of transplantation I did. Then the analysis of the fish assemblages in the area before the transplantation, and then a comparison between before and after. So some information. The transplantation I did was here in this small area. So we did a surface of 125 square meters with 4 fragments per square meters, or a total of 500 fragments. So it was only done here because there were early signs of a bleaching event, and because the corals are already stressed by the transplantation progress, we didn't want to stress them too much. So we postponed the transplantation until the sea surface temperatures would go down, but they didn't go down for the remainder of the project. So then the analysis of the before. So almost all my surveys were dominated by this species, which is Abudevidus sexfasciatus, or the scissor-tail sergeant. It's a species part of the damselfishes, the Pomacentridae, and they are classified as a planktivorous fish. The interesting thing about this species is that they were mostly counted above the healthy parts. So they also accounted for the difference mostly, or at least the planktivorous functional group accounted mostly for the differences I found later on shown here. So the squares here are the healthy reefs, these are the restored, and this is the degraded area. And the PermaNova showed that these two here on the right side are significantly different from the healthy side in their functional groups. And this difference is mostly due to the planktivorous fish which we saw here before, which accounts for 66% of the dissimilarity and has an average abundance here of around 76 species, while in the degraded reef areas only 22. Then we go to the abundance. So the abundance I looked at both in the locations I had as well as in the sites. And in the sites you can clearly see that before the restoration took place, the degraded reef, which is then in this case both degraded and restored area, are similar to one another, but they have a significant lower abundance compared to healthy. And here we have a significant lower abundance compared to the other locations. Then for the Simpson's Diversity Index, it's quite a confusing scheme, but basically what you see is each location and then also the site within each location. And what you can see is there is a little fluctuation and only a few are significantly different from one another. But for me, they don't say much because the difference is not either in a location or from the same site. Then for the before and after, well, this was the result. There was no difference in either fish abundance in the area, a functional group change, or even a species composition change. So now to interpreting these results, I'll start with the discussion and then go on to the conclusion. For the discussion of the no effect of transplantation, because that's the part that I'm mostly interested in, that's due to probably the small sample size. Then you can say, okay, how can you fix this? Well, you can either use a different survey method, like video census or something like that, because underwater visual sensors can be quite an impact in the area. Fish are scared of you, you're swimming there, you make noise on the water. And also the limited samples I had might have an effect on this. That was seen because I did an analysis on the combined data of both before and after to see if I would pull this data together as all samples, if there would be a change in results, for instance, in the fish abundance in the area, if I would all pull, say, as the before data. And what I found is that p-values became lower. So with an increase in samples, either in both before and after, you might also find a difference. Then the biggest part that is a lack of replicates. Because transplantation only took place in one area and not in all 3 areas that I assigned, I don't have any replicates for the comparison of before and after data. And one of the most frustrating things was that I almost lost 90% of my fragments that I transplanted, which is also a big factor contributing to maybe not having a difference in fish in the areas. Then for the conclusion, so for the before, the differences between healthy and degraded reefs that I found is also corresponding to literature that say that a decreased coral cover is combined with a decrease in abundance of fish. Then the little variation of biodiversity is also something that I found in literature. I read a study by Geraldi et al. That did a oyster reef transplantation in an estuary, and they found exactly the same thing, that after introducing a new oyster reef in an estuary, the biodiversity didn't change. The only thing that changed was the abundance. So so what this means is that biodiversity doesn't necessarily have to change, but your increase in fish can be, so the fish that you see can basically the same species that you find everywhere, they just appear in more abundant numbers. And yeah, well, as I said before, there was no effect of transplantation. The recommendations for me mostly is do transplantation in a different time period. I did transplantation in the warmest period of the month. We had water surface temperatures of around 33, 32 degrees, and they were up to a depth of 5 meters. And also, of course, monitor longer. So, well, this was my presentation. I'd like to thank Leo Barret, who was my supervisor. I'd like to thank David Roat, who was my promoter. I'd like to thank everybody at MCSS, all the volunteers that came in, who helped me out with everything and the logistical problems I encountered. And I'd like to thank you for your final attention.